can start sharing the presentation if I found the Teams.
Okay, please do. Please mute yourself if you are joining, because it will be better to hear us and Alex. Okay.
But I'm waiting for a green light from your side.
Okay, I think everything is going well. YouTube is streaming right now our presentation, and I am admitting the people, so yeah, we can start.
Okay, so let's start the presentation. Welcome to everybody. My name is Michał Jankowski, and we would like to, together with Piotr, welcome you on our session about the new technology, Bicep. Together with Piotr, we are trying to make this event very interesting and invite the people that are changing our reality. And if you have any idea who we should invite or what type of the session you would like to see, just grab an email or grab any other social media account and give us a call or message, and we'll try to help you to grab that people and organize a very similar meeting. Today we have Alex with us, Alex Frankel. He will be showing the Bicep, the next generation of ARM templates. And we already discussed with him that everybody is allowed to ask as many questions as you want. So please be brave and grab the opportunity that we have one of the authors or creators of the Bicep, so we can get the knowledge about very details of the technology. If I don't know if I can name it technology or approach or the language, and also the question about the future of this language, and also maybe this chance to ask the questions to Alex give us the opportunity that maybe one of your ideas can be a next feature that will be implemented to the language. And last maybe announcement before giving the stage to Alex: if you want to track our events, you can just submit to our or subscribe to our newsletter. You can just visit azurepoland.pl. You will have information about the events that we are organizing. Also, you will find some kind of materials, information about the topics, and this is the things that I think they're very, very interesting for you. If you'd like to see the topic, you can use our form and give us know. And also, if you'd like to conduct a workshop or that kind of the session, just let us know, and we'll help you to organize that. And just go through the whole process with you. And that's all from our side. I hope you enjoyed today's session and you will have fun. Alex, the stage is yours.
Cool. Let me start sharing. And let me put this over here. And flip this back. Okay, cool. Can everyone see?
Yes, we can see.
Okay, great. Awesome. Well, thank you all for having me at your meetup. It's really awesome that we're able to participate in these meetups all over the world without necessarily traveling to that part of the world, although it would be nice if we could do that right now. My name's Alex Frankel. I'm a program manager on the Azure Deployments team. So Azure Deployments covers anything having to do with native declarative deployments to Azure. So that's anything related to ARM templates or blueprints or what if or deployment scripts, and now this Bicep project, which I'll give you a deep dive on. I have my contact information there. Please don't hesitate to reach out. We really enjoy starting these dialogues with customers or potential customers and helping them mature their practice, whether it's their practice in Azure generally or using infrastructure as code or whatever else you guys want to cover that you guys think we can help. So to start out, what is Project Bicep? I think we can actually just call it Bicep now. That is the official name, so I should edit these slides. Bicep is at like the highest level, it's a transpiler. And all that means is it's taking one language that's authored by humans and translating it into another language that is authored by humans. So in this case, it's taking your Bicep code and turning it into ARM template code by running this Bicep build operation. And then at that point, you have an ARM template. It's the same ARM templates that you may already be using today. And so you can use that to deploy any resource in Azure. And because we are just this light abstraction over ARM templates, anything that you can do with ARM templates, you can also do with Bicep. So we are at parity with what you can do in ARM templates today. And that's why and I'll talk about this more later, we are comfortable with you taking a production dependency on Bicep if you're ready to do that. If you're familiar with kind of how TypeScript works and its relationship to JavaScript, it's really the same idea. So TypeScript transpiles to JavaScript. That's exactly what we're doing with Bicep. So why are we doing this? We certainly get a lot of questions of like, why are you inventing another thing? We have so many ways of deploying to Azure. The reason is that, we want customers that are using Azure for the first time or only using Azure or using Azure as their kind of primary cloud or main cloud to have the best possible deployment experience. And we think that is what Bicep can do. One of the things that's kind of a common misconception, I think, of how people use Azure is ARM templates are actually by far the most popular way that people deploy declaratively to Azure. So there's a handful of declarative tools for working with Azure. There's ARM templates, obviously. There's Terraform is, of course, the other big one. Pulumi, there's this Farmer project that has started, and there's a handful of others. ARM templates is far and away the most commonly used. It's been around the longest, that's certainly part of it, but it's also very powerful in terms of how much you can leverage Azure with ARM templates. They're very reliable, even if they've historically been hard to author. So that's why we're investing in basically improving the ARM template experience all up. This is probably a more succinct way of describing why we're doing this. So Azure as a platform is super powerful, as you all know, in terms of what you can do and the different types of resources that you can leverage. But when it comes to actually working with those APIs with ARM templates, it gets really complicated really fast, needlessly complicated in terms of the types of things you have to understand and wrap your head around that are really foreign and really strange, and you can really get lost in the weeds quite quickly. So I'll go through kind of the core benefits of why you would want to use Bicep in the first place. And then I'll talk about a little bit where we are in the life cycle of Bicep and how the project started and where we are. And then I'll do some demos, and that can be pretty free form. I have like a set demo that I'm going to walk through, but we can take that in all sorts of different directions. So the first benefit, probably the most obvious benefit, is just an inherently simpler syntax. So what you're looking at here, you don't need to focus too much on the actual details of the code, but on the left-hand side is Bicep, and on the right-hand side is the ARM template equivalent. So you can see on the right-hand side, it's running off the page. There's a lot more just JSON kind of verbosity in terms of things like extra square braces and double quotes everywhere, and lots of just noise. And the reason for that is basically with ARM templates, even though it's in JSON, which is a language, so to speak, ARM templates themselves are a language. It is a domain-specific language already. And in order to get this to work, you have to shoehorn the ARM template language inside of the JSON language. And you have to come up with all sorts of like weird hacks to make that work. And that's why you get these expressions inside of strings, and that can get pretty gnarly pretty quickly. So on the left-hand side with Bicep, what we're doing kind of fundamentally is just eliminating all of that JSON noise and distilling it down to just the ARM template language. So we sometimes say Bicep is a new language, but really it's more of ARM templates v2, where we've kind of extracted the language from being embedded inside of JSON and then giving it its own file extension and its own language service. One of the main reasons, let me move this over so that Alexei gets credit for his great work. One of the main reasons people really like ARM templates, and this is just as true of Bicep, is this idea of day zero support. So ARM templates and Bicep are like a thin abstraction. Sometimes we'll use the word transparent abstraction over the ARM API. So you have, as soon as a new API in Azure is stood up, whether it's a private preview or a public preview or GA, that API is immediately consumable in Bicep. We are able to provide kind of type safety and validation over these resource types as long as they publish what's called their Swagger specification. Sometimes those Swagger specs are inaccurate or they haven't been published yet if it's a particularly like bleeding edge brand new service, but it will never block you from deploying that resource. So no matter what the resource provider team has done, if they exist in Azure, there's nothing that they can do to stop them from existing in Bicep, basically. The next big benefit is first-class modularity. So we now have high expectations of modularity in any programming language that we use. It's absolutely table stakes, whether it's PowerShell or TypeScript or C# or anything else. Modularity and the ability to reuse code and write small, manageable files is really, really important for productive software engineering, no matter what language you're using. With ARM templates, we had a way of doing modularity through linked templates, which some of you may have used and are familiar with. That was always a hack, basically. It was like very much duct tape and glue kind of solution where, yes, you could have separate files, but it required an incredible amount of understanding of how ARM worked to achieve a really simple thing, what is simple in most other programming languages. So this was a really, really big focus for us, and I'll demo how modularity works in Bicep. The next one, and this is probably the most important point, and this is a bit of a subtle point, so I'm going to spend a little bit of time on it. Bicep was built for toolability from the start. So from the second we started working on Bicep, we are always asking ourselves, well, how is this going to be to actually author this on a day-to-day basis? The team that works on ARM templates and Bicep, we didn't always work on ARM templates. And when we took over the space and we're figuring out, well, how can we improve this? One of the first things that we focused on was how can we improve the tooling for ARM templates? So we invested in this VS Code extension called ARM Tools that already existed but needed a lot of love. And we introduced things like syntax highlighting and kind of greatly improved the IntelliSense and validation capabilities in ARM tools for ARM templates. But we quickly realized that it was kind of pushing a boulder uphill because trying to build tooling after a language has been created is really, really hard to do because you've made a lot of decisions about how the language works that if you didn't consider how tooling worked at that point, it's really hard to kind of like do that retroactively. So with Bicep, we knew we had to think about tooling from the beginning, and we got some great advice and guidance and mentorship from some of the premier language experts across the world. You may know there's a guy named Anders Heilsberg who helped design C# and helped design TypeScript. He works for Microsoft, and he's been helping kind of guide how we think about programming languages and what's important when you're designing a new one. And this was the point that he emphasized to us the most. And so we as you are authoring Bicep, you may not notice how good the tooling is, but it's really, really good, and the foundation is really, really strong. I like to say that it really shares more DNA with a high-level programming language like C# and like TypeScript than it does with a configuration language like HCL and Terraform. So really good IntelliSense, really good validation. The next big difference and advantage of using some of the native tooling, ARM templates and Bicep, is there's no state management. Basically, ARM templates are executed service-side. So the runtime exists in Azure. You send Azure an ARM template, or you send Azure Bicep code, and then it processes it service-side. And there's no requirement to have a state somewhere, which is your representation of Azure or somewhere else. We can always work directly with Azure and do GET requests so that we can see, here's what your resource looks like right now, no matter if it was edited most recently by Bicep or by the CLI or by someone in the portal. And we can do kind of what if operations to say, here's my Bicep code, and then here's what Azure looks like right now. What are the differences that I'm going to expect if I were to deploy this? I want to go over the goals, but kind of more importantly, the non-goals of the project. The goals I've kind of gone through implicitly with the benefits. So we obviously want to reduce pain and lower the barrier to entry kind of first and foremost. We want to be a transparent abstraction, and all that means is we want to provide you with all the benefits of the platform, and we never want to get in the way, and we never want to have an onboarding process so that some new thing works with Bicep. If you're waiting on a new API version that has some new feature for a resource you're already using, you'll be able to consume that in Bicep right away. Modularity we talked about. Some of the non-goals, we don't want to build, one language to rule them all. So we get these questions probably most often, and they are in our FAQ now of the README. Why are you creating another new language? I kind of touched on this earlier, but the key thing is that we're not really creating a new language. We're really doing a revision of the existing ARM template language. So it makes sense to think about this as kind of ARM templates v2 rather than a net new language. And then the other question we get is, well, why aren't you investing more in Terraform? Terraform seems pretty good. Why not just make sure that Terraform has day zero support or parity, and then just call it a day? We actually have a team at Microsoft dedicated to getting Terraform to 100% resource and property coverage. That's a bit of a daunting task because there's a lot of kind of auto generation that you have to do and a lot of pruning of that auto generation after the fact. So Terraform, we want that experience to be as good as it can possibly be. And really, we want all the clients of Azure to be perfect. We want the portal to be great. We want CLI to be great. We want PowerShell to be great. We want the SDKs to be great. We want Bicep to be great. We want Terraform to be great. We want Pulumi to be great. Because really, we are most interested in providing Azure the platform to you and you being able to consume that platform in whatever way you prefer. And you can be as efficient as possible and use the tools that you like best. So we are not trying to create Bicep so that we can move everyone over to it because we think that's the right way to do it. We just think Bicep is a way to do it, and we want that experience to be as good as possible. The other non-goal is we don't want this to be a general purpose language. That would kind of expand the charter too much. If you have kind of like intense data processing needs or something of that nature, it may be more appropriate to do that in a more traditional high-level programming language or a script and a pipeline, and that's totally fine. And you may be doing that as kind of like a pre-execution task and passing those values to your Bicep code as parameters, and then letting Bicep do what it does best, which is deploying resources. And then lastly, we're not out here to just invent new technology. As fun as that is, we don't have enough time to just invent things because that's fun. So we're really just doing this to meet some serious customer pain because so many people are using ARM templates. There's a huge interest from us to lower that barrier to entry and make people more efficient and deploy successfully faster. And that's really fundamentally what the project is about. This is the last slide before the demos, and I'll stop to see if there are any questions that people want to ask or have asked in the chat already. So right now, we are in our v0.3 release. We released this at the Spring Ignite, which was in March, and this was the first time we said we were production ready. So if you've been paying attention to the project, we've done a v0.1 and a v0.2 release with many minor releases in between. Where with v0.1, we just got it out there. We told people really early, perhaps too early, this is what we're doing. This is kind of how we're thinking about the space. This is roughly what we want the experience to be like. And we just introduced like the basic primitives, and you could do a very limited set of scenarios. But that started to build the community for us. It was really helpful. People tried things really early, and we got just a ton of awesome feedback. With 0.2, we really started to leverage all the kind of type system and type safety that we had introduced in v0.1 but weren't leveraging it. So we introduced validation for all the Azure resource types. We introduced IntelliSense. We introduced Modularity, and this was a really fantastic release, and you could do a lot more than what you could do in v0.1. And then 0.3, like I said, we were focused on getting to production ready. And so the key components of that was one, reaching parity with ARM templates. So there were a lot of people waiting on the ability to do loops and conditionals, which were capabilities in ARM templates that we somewhat recently introduced into Bicep. We integrated it with Azure CLI and PowerShell. And what that means is instead of having to build the Bicep code into ARM template code and then deploy it, we can do that on your behalf now. So if you go into AZ CLI and you say, I want to create a new deployment, you can now pass it a Bicep file, and we'll turn it into the JSON on your behalf and send it to Azure. You don't have to see a JSON file. We do that all in memory. But if you do want to see the JSON file for whatever reason, you can always build that and inspect it and use any other tooling that you may already be using with ARM templates. We have a decompiler. So for those of you who are eager to migrate off of ARM templates and onto Bicep, we have a decompiler. So that'll take your ARM template code and turn it into Bicep code. That's machine generated. That is a best effort process, but it will save you some just like pecking away on the keyboard. It'll get everything over pretty efficiently, but there may be things that you want to refactor after. You may want to rename some of the symbols and the variable names and things like that that we had to auto-generate. And then perhaps most importantly, with 0.3, we introduced support with Microsoft support plans. So if you have Microsoft support, you can now open support cases with Bicep issues. So if you're running into something and you don't want to open an issue, you want it to be tracked and have an SLA behind it, you can open up support cases, and our support team is fully trained and they know how to reach out to us if necessary. And we have a great relationship with our really excellent support team. I will switch over to a demo, but any burning questions that I can answer in the meantime?
In the chat, I saw there is a question about if we can use it in the production already. And for everybody, just don't be shy, unmute your microphone and just grab a chance to ask Alex directly a question. And the people that are watching us on the YouTube, if you write the question there, together with Piotr, we'll just pass it to Alex.
Cool, and I'm gonna scroll through these in the meantime.
I'd like to ask a question if possible. It's Paul Mulcready from Conditionals.
Yeah.
Alex, we're using it as part of a large data center migration for a UK bank, and the way we currently use Bicep is we author our Bicep files and then we're creating template specs from them. And then based on those template specs, we're dynamically creating a blueprint through a PowerShell script, and then using that blueprint to orchestrate the deployments. I guess the question from my side is, do you see a future for blueprints, or would there be another way that you would recommend us orchestrate the deployments of the template specs?
Yeah, good question. So I'll share a little bit of context into kind of what the state of blueprints is and how it fits into the larger picture. With blueprints, this was, pre the work that we were doing on ARM templates and certainly pre-Bicep. With blueprints, we wanted to create this kind of like Azure native package that you could put into Azure as a resource, RBAC it, and then have a way to deploy that as a way of stamping out new subscriptions or new environments, which worked great, particularly if you were kind of on Rails in the portal. When you switched over to blueprints as code and you reach that kind of next level of maturity, that's where the experience starts to break down a little bit. And the reason for that is because the blueprint definition is its own schema, and it had its own functions and own parameters. And we kind of created a fork in the road where you could really choose between linked templates as your way of breaking things down and creating a package, or blueprints. And you could use artifacts and bring in templates and create that package that way. We've been doing a lot of work behind the scenes, and we really haven't been able to talk about it too much to kind of align the whole picture so that blueprints takes a dependency directly on templates and template specs as its schema. And so what that means is that the blueprint schema is kind of going to go away and be retired, and you will use template specs as your blueprint definition, basically. So it'll follow a similar workflow to what you're doing now, but you won't have to actually create the blueprint definition. You'll just create the template spec, and that thing that you deploy, instead of creating a blueprint assignment, you will deploy the template spec directly. Now, there's one piece that doesn't exist yet that will exist hopefully in a month. We're working on it right now. It's called deployment stacks, and it's going to be kind of the long-term future of what blueprint assignments was doing. So blueprint assignments would kind of keep track of the life cycle of the resources. So it would know what version that you had deployed and what resources it was managing, and it would lock the resources. Deployment stacks is going to do all of those same things, but for any ARM template, whether it's a template spec or a template from a local machine, you'll be able to create a stack out of that. And what that's going to do is kind of expand what blueprint assignments weren't able to do. So blueprint assignments targeted a subscription, that you couldn't target a management group, you couldn't target a resource group. A template can target anything in Azure. And basically you'll get all the lifecycle goodness of a blueprint assignment, but for any template at any scope in Azure, and you'll be able to lock resources and whatnot. So that is a long way of saying that your workflow, most likely going forward, will be you'll author Bicep code, create template specs out of that, and then deploy those as deployment stacks wherever you need to deploy them to whatever scope in Azure.
That's great. Understand. Yeah, thank you very much.
Yeah, absolutely. Paul has his hand up.
I do. I hope my mic actually works.
Yep.
Does it? Yeah, good. So just expanding upon that, you say this other template stack will be available within hopefully a month, right? That's great. That's probably going to be, beta stage, right?
Yeah, private preview.
Yeah. So do you have like a plan of perhaps an idea of how long that might sort of get to the stage where version 3 of Bicep is now?
Yeah, so we're going to do private preview next month and hopefully public preview, 2 to 3 months after that. And at that point, we're going to start encouraging migrations from blueprint definition and blueprint assignment to template spec and deployment stack. And we're going to provide some tooling to help make that migration straightforward. Because Blueprints never left preview, we feel comfortable starting the migration when Stacks is in public preview. And so hopefully by August, September, you'll be able to start migrating things and having a really clean end-to-end from Bicep all the way to deploying that code as stacks. Now, having said all that, we treat Blueprints as a GA service because it's been out for so long, and there's frankly a lot of large customers using it in production. So we have an obligation to maintain those APIs and help with any migrations. And it'll be those APIs for blueprint definition and blueprint assignment will eventually be deprecated, but on a GA timeline, which means it will be 1 to 3 years before those APIs actually get deprecated, and we will continue to support it. So if you were to have an issue with existing blueprints, you'll get the same support that you get today. So there's no rush, there's no big push to do the migration, but hopefully life is better on the other side, so that'll make that a little bit easier.
Okay, and just to clarify, when you say we, it's still within your little team, right? So
yeah,
yeah, okay, cool.
Yeah, exactly. So you can email me and yell at me, and we'll figure it out from there.
No, invitation there already accepted.
Yep. There's one other person with their hand up, I think. Kevin?
Yeah, that was me
Okay.
previously. Quick question about integration with Azure DevOps and the pipelines, because right now I don't see any working tasks. I know that it's possible to create a custom tasks for that, but any plan?
Yeah, we will get to that. Someone told me that it works with the current DevOps extension, that you can provide it a Bicep file and it works. I haven't personally tried that. We haven't tested that, but maybe it does work. So right now, the best way to integrate it into a pipeline is to use the AZ CLI task and use the deployment command in there, and then just pass the Bicep file. So you'll do AZ deployment create, and then point it to a main.bicep file, and everything just kind of works from there. And the CLI has been updated in DevOps and in GitHub Actions. So as long as you're using the latest version, everything should just work. It will be approximately the same amount of code, possibly less lines of code than using the official extension. But we will eventually make sure that that extension works, because we know a lot of people enjoy using that kind of more on-Rails guided experience. So we'll get to that eventually. It's just not as high priority for us because we have the CLI and PowerShell integration. And thank you to whoever shared the CI/CD link. That kind of shows the rough overview.
Yeah, I saw this link earlier, and I like a clean tasks without any noisy like CLI, because nobody know who will be maintenance pipelines after years, days, months.
Yeah, makes sense. And there are, I think there's some more links being shared, so thank you. There are some Bicep dedicated extensions that are just community maintained right now. So some of those may do this as well. So it's worth exploring what's out there, but we will eventually get to the official extension. And then Kevin had his hand up.
So looking on the chat, we have 2 more questions. The one is, can we use Bicep 03 version for the production environments already?
You can. Yep. So there shouldn't be anything that you can't do in Bicep. And oh, Kevin, I'm hearing an echo, I think, from your side. But yeah, you should be able to do everything, and then it's supported the same way ARM templates are supported at this point. So if you have issues, you can open up support cases.
Yeah, and the second questions that I can see that we didn't answer. There's a question, as a beginner, should I start learning first ARM templates, or should I jump into the Bicep directly? But I think the answer is easy, Alex, yeah?
So I think you're better off just going straight to Bicep. I think there's just a lot more kind of conceptual overhead that ultimately is not very important. If you use ARM templates, like learning link templates and stuff like that doesn't really get you anything. learning ARM, learning how Azure works at an API level is super valuable. You may not want to do it right away, but understanding like core concepts like resource types and resource providers, resource IDs, kind of resource paths, and how things talk to each other is really will pay off over time. Bicep teaches a lot of that kind of inherently because you have to understand what a resource type is. We don't hide that very intentionally. So you learn a lot of that through Bicep, and I think in a pretty efficient way. So yeah, I would encourage you to start straight with Bicep.
Okay, and we have Kevin.
Yeah, sorry, can you hear me this time?
Yep.
Fantastic. Sorry about that. So back to the Azure DevOps GitHub like pipelines, but with the deployment stack piece you talked about that's coming up. Will we see modules or commands come into the pipelines? Like I know there were some blueprint ones people had started trying to put blueprints in the pipelines. Will we see that functionality integration come down the line at some point? I imagine not at the beginning, but maybe some point during the lifeline with that.
Yeah, for sure. It'll be the same story for stacks as with Bicep, where we'll just encourage using the CLI or PowerShell to create stacks out of Bicep files. But we'll eventually update that DevOps task and the GitHub Actions task to create stacks natively from Bicep code, where it'll be pretty efficient at that point.
Awesome. Thanks.
Yeah. And then I see Darius asked a question about secrets. So secrets, the recommendation for handling secrets is to use Key Vault. And ARM templates and Bicep have good integration with Key Vault so that you can provide a reference to a Key Vault secret, the resource ID of the secret. And as long as all the permissions are set up correctly, we can retrieve that secret as part of the deployment, and we don't output it or emit it anywhere as part of that end-to-end. If you don't want to keep the secrets in Key Vault, we have a notion of a secure parameter. And when you're using a secure parameter, we will also just not output that anywhere. You'll pass the secret to the deployment directly in a parameters file or on the command line. So it's up to you to make sure that that secret is passed in correctly if you don't want to use Key Vault. But once it's passed to us, we handle it appropriately so it's not emitted anywhere. No problem. Any other questions before we start looking at some code?
I would say let's start to look at the code to present also the newcomers how the biceps looks like.
Let's some code. Let me minimize this. Cool. Okay, so I'm in VS Code, which is the only extension or the only IDE or text editor that we officially support. Although the language service, so the code that is running when you're authoring Bicep code, that's built with something called the Language Server Protocol, LSP. All that means is it's a generic protocol that most IDEs support. So if you're eager, you can get that language service running in any IDE. We had someone get it working in NeoVim, which is, I guess, an expansion of Vim. So that was pretty cool. And it can work in Atom or any other editor, but we're focused on VS Code at the moment. We'll eventually get to Visual Studio, but we want to focus on VS Code right now. To get support up and running, you'll notice VS Code recognizes the Bicep language because of the Bicep file extension. All you need to do is install the Bicep extension. So this is available in the marketplace and you can install it. And actually, when you create a file with the Bicep file extension, we'll prompt you and recommend that you install this extension from the marketplace. So pretty straightforward to get going in that regard. And then when we deploy, you need the Bicep CLI, and I'll talk about how you can get that as well. So right now, the only Bicep file I have here is a file called applan.bicep. So we're going to author from scratch a server farm or an app plan, depending on what context you're seeing that in, and a website on top of it. And we're going to use modules to kind of tie everything together. So to start out, we're going to declare a resource. That's kind of what we're all here for. So I'm going to use the resource keyword, and then I give resources a symbolic name or a symbol. So I'm going to call this app plan. I could have called this foo. I could call this whatever I want. This is just a variable. And then at this point, I get IntelliSense and completions for all the different Azure resource types. So you'll see it's obviously a big list. We didn't decide to make it a big list. It's just Azure's grown quite a bit. So there's a ton of resource providers and a ton of different resource types. You can scroll through and search for them, or you can just start typing the resource type that you're looking for. And so I'll just hit enter here, and then it's going to ask me which API version I want. More often than not, you're going to want the most recent one, unless you have a particular reason to pick an older one. We're actually thinking about a feature to just automatically select the most recent API version, but right now you make a separate selection. And then at this point, I'm going to type equals. You're seeing IntelliSense for another keyword called existing, which I can talk about in more depth. But basically, that's a way to get a reference to an existing resource. So if you have a key vault and you need to get a reference to the secret, or you need to get a reference to a container registry to pull secrets from that, you can use the existing keyword to do that. And then after I type equals, and by the way, you're seeing a very recent release of Bicep. This has some of the stuff that we're going to kind of talk about in our 0.4 release. So you're getting a preview, although you can actually get this version of the extension right now. You'll get IntelliSense for the different ways that you can kind of deploy this resource. So you can do this iteratively. So you can do a loop. And we have a few different snippets for doing loops. You can conditionally deploy this resource. You can just do a blank resource declaration, which is what I would normally demo a couple weeks ago. But now we have a couple new IntelliSense options here for the required properties and a snippet if we have one. So we have a growing library of snippets for popular resource types. And I can just select this and it'll populate the list for me. I'm going to actually select required properties. And these are the required properties based on what Bicep understands from the resource provider's Swagger specification, from their API definition. So we don't directly control what server farm's specification looks like. And actually, you know, I sometimes go back and forth on showing this example because their Swagger is a little bit incomplete. So their required properties show as name and location, but they actually have more required properties. So the IntelliSense experience for websites and server farms is not as good as it could be, and we're actually working with the team to make sure they do as much as they can there. But for any resource type and for most resource types, we have a pretty good API definition, and you'll get pretty good IntelliSense there. But we can go through here and use what they have and then finish the resource definition. So I'm going to just call this app plan, and then I'll just tab through and I'll do resource groups. The resource group's location is the location of the resource, so I'm not hard coding a resource location. And then you'll see that even though there are some required properties here that aren't marked as such, those properties still show up here. So I do need a kind, and the kind is going to be Linux. And again, there should be completions here for the different kinds. They don't have that. We're working on that. And then I need a SKU. So I'm going to do SKU, and that's an object. And you can see all the different SKU options we have here. The only one I need is the name, and I'm just going to call this B1. And then I'm going to add one property, and you'll see I'll continue to get IntelliSense through these properties. I have all the different properties here that the server farm exposes. The only one I want here is reserved, and I'm going to set this to true because I want this to be a Linux app service plan. And that's a complete resource definition for the server farm. And you'll notice this is exactly what you would be required from an ARM template. So we're intentionally not hiding anything from you in terms of what this resource requires and the different properties that you can set. And so that's what we mean when we say we're a transparent abstraction. We probably want this to be more of a dynamic resource definition. So let's add some parameters. So we'll add a name prefix. And it follows a similar structure of keyword, in this case param, the name of the symbol, which could be anything. I'm just going to call it name prefix, and then the type, and this is a much simpler set of types. So we just want this to be a string. I'm going to leave this without a default value because I want whoever's consuming this file or consuming this resource type to have to pick their own name prefix. And then I'll add another one for SKU. And this is also going to be a string, and I am going to default this with equals. So I'm going to call this B1 SKU. And then for the name, we're going to use this name prefix. We're going to use string interpolation. If you're familiar with string interpolation in any other language, it works very similarly. This is the equivalent of doing the concat function. So if you've used ARM templates, you've seen concat basically everywhere. And that's one of those things that gets very verbose very quickly that we can distill down and make a little bit simpler using some common conventions from other programming languages. And then we'll replace the SKU. We'll just say SKU here. And you'll notice I don't need to use like the parameters function or anything like that anymore. You can just reference the symbol directly. So this is the of this. And then lastly, we're going to output some important information that we may need when we're consuming this. So we're going to use another keyword output. We're going to call this plan ID. It's also going to be a string. And then we're going to say it's equals to the app plan. We're going to get a property from the app plan symbol. So I get IntelliSense here for the app plan resource, that symbolic name. As you use Bicep, you're going to realize you use these symbolic names all the time, because really one of the things you're very, very commonly doing is declaring resources, getting resource IDs from them, or getting other properties, wiring these resources together by getting a secret reference or something like that. So we're going to do app plan, and then we're going to do dot, and then we get all the different properties that are exposed or hang off of this symbolic name. So I just need the ID here, but I could get any other property from this. So if I do dot properties, these are all the different properties that it exposes when you do a GET request. So if you go into the portal and look at a server farm resource, these are the different things that that are actually exposed and you would see in the UI, or you would see if you did a GET request. This is a larger list than what you would provide on a put request when you create the resource. So we provide really good IntelliSense. This is one of the things that we never got to in the ARM tooling that we've made kind of first class in Bicep. And so that's really nice and a really good way to just explore what these resources provide. So I'm just going to do app plan ID, and then that's all we're going to do here. So I'm going to save that, and this is going to be the exact file that I want to consume whenever I want to create a server farm. If I want to, I can show you guys the equivalent ARM template code, but this is not needed. So Bicep is integrated into the AZ CLI. I can do AZ Bicep build and then point it to applan.bicep, and this will generate the equivalent JSON file. So this should look more familiar. If you've ever written an ARM template before, it's already relatively verbose. So we have 42 lines and a lot more characters. We have 1,000 characters here. With this equivalent Bicep, we have 17 lines and 300 characters. So you're not always going to reduce the number of lines so dramatically, because these resource definitions are usually the source of the number of lines, but you will greatly reduce the number of characters that you're writing, which increases your authoring efficiency, but also makes these things a lot more readable to someone else who's going to manage that code after you. So we can get rid of this JSON file. Let's just delete it because we don't need it. And let's author our main.bicep file and show how this gets consumed as a module. So instead of, well, actually, let's do this. We're going to set the target scope to be subscription. Target scope, all that means is that this bicep file is going to target a resource group or target a subscription or target a management group. In this case, we're going to target a subscription. And our goal here is to create a resource group and then deploy that server farm to that new resource group. So we're going to use the resource keyword again. We're going to say resource RG, and then we're going to look for resource groups, resource group. We're going to pick the most recent API version. We'll do required properties, and then we just need a name. So we'll call this a.frank RG, and we need a location. In this case, I'm going to pull the location of the deployment resource, again, because I don't want to be hard coding locations. And then now we're going to use one more new keyword called module. We're going to call this app plan deploy. Well, app plan deploy. And then I get IntelliSense for the different bicep files that I can consume, whether they're in this current directory or I can explore other directories as well. And then again, I just do equals, and I get required properties even for a module, which is pretty nice. So I'll do required properties, and I'll see that I have a few different required properties here that I'll go through. So the first one is scope. And the scope property in this case is expecting a resource group. That's what it's telling me. It needs a resource group type thing. And all that means is that it knows that this module is set to be deployed to a resource group. So you need to provide a resource group in order for this to deploy successfully. So I'm going to give it the resource group that we just created. Modules have names, so I'm just going to call this app plan deploy. I could call this whatever I want. And then I have a set of parameters, and this is based on whatever the module author described in their module file. So in this case, I have a name prefix. I'll just say a.frank here as well. And now I have a full module declaration. And you can see now that having these main files that call out to these other module files makes the authoring really kind of clean and efficient, because my main file is relatively simple and I leave all the complexity to the different module files. Any questions so far? I have a few more things to show, but I want to make sure I'm answering your questions.
Yeah, just one regarding applan.bicep second line, the other file.
Oh, yep.
Yeah, in the second line there is B1. It's default value or hard-coded value?
Default value.
So if I pass another one, it will be another one. Okay. Cool.
Yeah, exactly. So I actually will see that I have other parameters here if I want to change this. So I could change this to F1 if I wanted to. And if I set allowed values on here, so I can do, these are called modifiers for your parameters, or decorators we sometimes call them. I can do allowed values here, and this is an array of strings. So I can have B1, and I can have F1, and I can have whatever else I want here. And then when I go and do IntelliSense here, it knows that those are the two options because it's set as allowed values. So wiring these things up and declaring modules gets pretty efficient because we know enough about what is required for any given module instantiation. Any other questions?
Alex, your module file is local to your other bicep files. So is there any plan to have support for remote modules? So, for example, a module might be in another Git repo, and you could sort of pull that module in from that external Git repo, or
yes,
another private Git repo that you've got access to.
Yes, great question. So for 0.4 is what we're releasing at builds. It'll be right after builds, and then we're going to do our 0.5 release, and the main focus of that is to provide what we call a module registry. So the ability to pull in modules, not just locally, but from external sources. That could be a private Git repository. It could also be, we're going to have a public module registry where we as Microsoft can publish known good modules that we can kind of support and recommend, and also take contributions from the community for other types of modules there. And
Thank you.
O.5 will hope to get out end of July, early August. We're trying to do like 2-month release cycles.
Thank you.
Alex, a question about like unique naming for whether it be like app plans or not. Is there a strategy for looking for an existing app plan you may have already created, like, you know, a.frank 001, and if it exists, deploy this as a.frank 002?
We don't have that. At the moment, we're not doing any round trips to Azure, so we can't say something that already exists. So pick another one or something like that.
Right. You can use the. Okay, so like I could do existing to look for a specific one, and if it exists, do a different name, but I can't have it check all of them or anything like that.
Yeah, right, exactly. So, but even when you author an existing resource, so if I were to change this to existing, I'll get some validation issues here, but it won't be able to say, I can't do like control space here, and it'll look up all the different potential existing resources. You have to know that a certain resource exists with a certain name.
Gotcha. Okay, I see. So then you can just always, you can go out and update existing 001, but I can't use that to then deploy 002.
Correct. Yeah, it's not.
Yeah,
it's
I was thinking like a Boolean true exists, yes, and then go from there.
Yeah, it's not that smart. And then existing is only for getting a reference to an existing resource. It's not for updating an existing resource. If you wanted to update, so anytime you're declaring a resource, we use that word declaring because we actually don't know if you're creating or updating. And ARM doesn't understand the difference between a create and an update, because ARM is, we use the word idempotent. And all that means is that you're trying to reach a final state where you want this resource with this name to look this way. And it doesn't matter to us if the resource already exists or you're updating the resource with new properties. So there's no distinction here between create and update. And then existing is only for getting that reference if I need to get the ID or get another property. And you'll see that these properties become invalid. And it's saying you can't use properties with an existing resource. And the reason for that is because we can't update it. There's no notion of changing the properties here. So there's only a handful of properties that are supported on existing, and it's only enough properties so that we can construct the reference to do a GET request, literally, to figure out what that resource looks like and get the properties from it.
All right, cool. Thank you.
That makes sense?
Yeah, it does. Thanks.
Cool.
On Alex, on output as well, the output, if you did the actual whole the whole object, say it was the whole resource, say it was virtual network, and you did output on the actual resource itself, would you get the JSON for the whole of the virtual network?
You should. So if you did app plan here and object, and you made it equal to app plan, which we allow this.
Okay.
This should be the whole, as if you just did a GET request. I happened to just see an issue, I think opened yesterday or the day before, where something wasn't working as expected. We haven't had a chance to triage this, but this should work. So there may just be a temporary issue that we need to resolve there.
Right, okay. It's just we're looking at ways of doing infrastructure testing as well. So I'm just wondering whether or not we could use existing in conjunction with output to then say, well, this is the actual state of our infrastructure. Now test that output object or that output result to see whether or not the infrastructure state is as we would have expected it to be.
Yeah, that's fair. One of the things that we want to expand, so you're kind of touching on something that's a little challenging with Bicep today, which is if I have a resource created in one module and then I need to reference some property of that resource in another module, you have to output the relevant properties of that resource when it's created, and then kind of reestablish the reference to that resource with the existing keyword. And that's just a lot of extra code to get to a fairly simple thing. So what we're going to be adding, it'll be sometime between 0.4 and 0.5, is the notion of a resource type for an output. And at that point, you won't need to reestablish the reference because you'll have a resource a parameter of type resource that you can then pull that in and then query it as if it was an existing resource that you had declared. And that's going to create kind of the world between modules. We're gonna have a richer understanding of passing resources, which is something that's very fundamental. And it's going to make a lot of different scenarios really kind of efficient and really easy for us to validate. So I think this is going to be a really big positive change once we're able to implement it.
That's great. Thank you.
Mm-hmm. Michael, Peter, how much time do I have? Sorry, I don't know how much more time I can go.
Depends how much you have. To be honest, I think we have half hour or 1 hour. Depends how you would like to do something more or show us.
Okay.
The question is also for you and the audience. If the people will be just leaving, Alex, will you know that probably we should finish? And if somebody has hard stuff, just let us know on the chat, and also you can see what time Alex should contact this session. I can see the hand also from the poll. Maybe last question before going further.
Sure.
Yeah, hi, sorry. Just touching on McCready's last comment about modules and whatnot. You know, CAF is a bit of a buzzword. It's been knocking about, you know. Is that kind of something that you're sort of leaning towards in that area?
We work CAF, you said, right? CAF?
Yeah, that's right.
We work with the CAF team to make sure they're kind of up to speed with what we're doing and where we're driving, as well as there's a initiative called Enterprise Scale Landing Zones that's also kind of involved in some of the CAF work. We don't kind of own what that work looks like and the content that they're producing, but they're aware of what we're doing and they're making sure that they keep their content up to date to make sure that I think their focus is really kind of like Bicep and Terraform as their kind of two go-tos when they offer a solution or an implementation of something. So they're pretty caught up with what we're doing.
Okay, cool. Because I was just sort of thinking the link where you said we're going to probably offer some sort of modules that you can pull in like an SSH type thing. And I was thinking, isn't that what CAF really kind of does, I guess? Yeah,
so I think we'll definitely plan to have, you know, CAF modules. Like today, there's CAF built-in blueprints and some enterprise scale templates. Those are great candidates to be in the module registry as kind of public Microsoft published modules.
Right, yeah, thank you.
Yeah. Cool. Any others before I keep going?
I asked the question on the chat.
Let me look. Sorry. Can you create a resource which will store a password and it will then be used as input for some module, and will that password be kept between rerunning deployments? So you can create a key vault secret in a Bicep file and then reference that secret wherever you need to. We actually just finished an implementation of that. So you can create a secret with Key Vault. So we just leverage the resource provider there. There's no notion of creating a secret in the Bicep runtime, so to speak, if that makes sense.
Yeah, thank you.
Yep. Cool. Okay, so we have a resource group, we have an app plan, and actually I don't know what's in this resource group, so I don't know how well this what if is going to go, and I don't think we're going to deploy it just yet. But let's see what it's actually looks like to work with this file when we talk to Azure. So I'm going to use the AZ CLI. I'm going to do AZ deployment group or sub create, because this is going to target a subscription. And I'm going to point it to my main.bicep entry point. and I'm going to give it a location because subscription deployments require a location. I'm going to do ECUS because I'm in New York right now. And I'm going to do -C, which is short for confirm with what if. So this is just going to run what if for me in advance of doing the deployment. It's going to ask me, it's going to say, here's the output. Do you want to proceed? So what it's doing right now is it's taking the Bicep code, translating it into the JSON, resolving all the functions and the parameters and the dependencies, and then comparing it to whatever exists in Azure in the subscription. And so in this subscription right now, this resource group doesn't exist. And here's my server farm, and here's my resource group. And it's telling me that both of these are going to be net new creations. And if you're paying attention really closely, you'll notice that there's a tag here that I didn't add in the code. And that's because there's a policy in this subscription that's set to add the cost center tag to everything in the subscription. And so what if is actually able to resolve that there's actually policies going on, and that will modify what your resources are going to look like. So what if it's not perfect? There's definitely some issues with what if that we're continuing to improve, but it's a great just like check to do, and it's good to get in the habit of just running the what if and seeing what the output looks like to make sure there's nothing surprising, to making sure that, oh, I thought I was going to create this resource, but it's actually going to update it, or there's something that's going to be deleted or removed that I wasn't expecting. So I want to make sure that I'm making sure the deployment's going to work as expected. And then at this point, I can just say yes, and it will actually proceed with the deployment, but I'm going to say no because I don't want to wait for that to finish.
Alex, can I ask a quick question?
Yeah.
What about the converse of policy in terms of, what happens if if you had a policy that was enforcing a specific naming convention and you didn't conform to that? So, it's giving you an output saying I'm going to add this tag, but, would it also potentially give you an output say, actually, this isn't going to work because this policy is going to block it?
It will tell you that. So it will check against deny policies. If you're violating a naming convention or you're missing a property that needs to be there, it will check against that. What if won't check against all different policies types? So the big one that we don't support yet is audit. So if something was going to be allowed to be deployed, but it would be flagged as non-compliant, what if isn't able to catch that today? We'd like to add that, but it will catch modify, which is what the tag was, and it will catch deny, and those are kind of the crucial ones. So it's a great thing to just kind of get in the habit of checking. And it's another one that's because of the native integration and the native nature of Bicep. It's not something that Terraform is able to check or Pulumi is able to check in the same way, because they're kind of taking over a lot of the responsibility that ARM does, the deployments engine, and the deployments engine has kind of more access to things like policy. So you usually get richer validation with Bicep than you do with some of the other alternatives.
Yeah, that's great. Thanks.
Okay, so now we have a server farm, we have an app plan. We'd probably like to, app plan deploy. We'd probably like to deploy a website. So we have very conveniently an ARM template here. This is just a regular ARM template. It deploys a website. It uses Docker to pull a container image, and that's how it's instantiating the website. I'm not going to touch this this JSON file. I actually want to decompile it. So I want to take this Bicep file or this JSON file, and I want to do decompile, and I want to say -f, and I want to point it to good ARM templates site.json, and I'm just going to run that. And that's going to emit the Bicep file. And I'm just going to move it out of this folder and make it in the top level directory. And you'll notice it does a pretty good job of converting the parameters. It converted a concat function that I had into string interpolation. So it does a pretty good job. It's not always perfect, but of moving this over. And now we're just going to consume that as yet another module. So I'm going to do module, site deploy, and we're going to do site.bicep, and we'll do required properties again because this is just too convenient not to do. And we're going to do RG. We're going to call this site deploy. We need the app plan ID. So we created this module, the app plan module, but we need to get that ID out of that module and use it as the app plan ID for the website. So we're going to do app plan deploy, and then we're going to do dot property access. We're going to get the outputs, and conveniently we set our output to emit the plan ID. And so this sort of wiring together that I said was so common just gets really easy. You can just kind of type away and explore what these modules provide. And as long as the module has been authored correctly with the right outputs, it becomes really easy to wire these things together. My Docker image, I happen to know I want to use a Docker image called Nginx demos hello. And I also happen to know that I want to use the latest tag. And then I have a name prefix. We'll just say a.frank here as well. And now I have my website. So now I have my resource group, I have my app plan, and then I have my website that's going to target that app plan. And notice that I haven't thought about depends on at all. So if you're familiar with ARM templates, you're definitely familiar with the notion of depends on. Basically, you had to know the exact order that things needed to deploy. And if there was a dependency, you had to explicitly set that dependency. But because we have these symbolic references, so here's a symbolic reference, here's a symbolic reference, we know that this app plan can't deploy to this resource group until the resource group exists. So if you were to actually compile this into the JSON, you would see all the depends on are still there. They're still required, but Bicep is smart enough to wire up all those dependencies on your behalf. And in practice, 99% of the time, you shouldn't have to think about depends on. There are some rare cases where the resource is doing something that doesn't directly connect to another resource. And so you need to know that there's a dependency there. But most of the time, you're not thinking about dependencies, which is just a fantastic improvement. There's just a ton of, it was such a common error to make, and it was something that you knew the second you saw it, or sometimes you didn't, and you could fix it. But it was one of those paper cuts that we are able to materially improve with Bicep. I will show, let's show a couple more things. We have loops support, so we kind of overhauled how we think about loops. In ARM templates, this was called copy. Sometimes copy loops is what you would hear. With Bicep, we have a much more familiar syntax for doing looping and doing conditions. So we'll create a variable, var sites, and it's going to be an array of objects. And the array is going to have the image name, or what's going to be in here. The tag is going to be latest, and the name is going to be fancy. And we're going to have another object. We're going to call this plain text is going to be the tag, and the name is going to be plain. So now we have an array, so something that we can iterate over. This happens to be a variable. It could be a parameter. It could be something else. And we're going to modify this resource declaration to use the looping syntax. So I'm going to add some brackets here. And then I'm just going to say for site in sites and colon. And now I have my loop set up. But I'm getting a warning, I think, because, yeah, I'm getting a warning because I'm not actually referencing the site. So this, if I don't do anything, it's going to deploy the exact same resource twice, and I'm going to get a conflict because it's going to have a name conflict. So I'm going to modify some things here to reference the site loop variable. So I'm going to say site.name in the site deploy name here, and I'm going to do the same thing here. So I'm going to change the tag. I'm going to say site.tag. And for the name prefix, I'm just going to say site.name here. And now I have a loop. So now this is not going to create one website, it's going to create several websites. And if I wanted to add some more, it's fairly trivial to add more here. So if you have n number of subnets or n number of access policies, there's a variety of things where you need to iterate over a list. This is a much cleaner way and coherent way of describing this than how you had to do it in ARM templates, which was pretty foreign with the copy property. The last thing I'll show is another new thing that we'll have for 0.4 that you can get today, which is the visualizer. So we have a nice little way of exploring these resources. If you have a really large deployment, or if you want to show exactly what's going to be happening to a client and they don't want to look at the code, this is a pretty good way of representing what's going to happen with the dependencies kind of mapped out. And so if you're also struggling to understand, well, what is the order that these things are going to happen? How does it know what the order is going to be? This is a really great way of viewing the dependencies, and it knows that this is in a module, and then there's one resource in the module, and so on and so forth. And it scales pretty well. And the reason it scales pretty well is because it's working kind of directly with the Bicep language service. So the same tooling that makes the IntelliSense so good and the validation so good is also what makes the visualizer so good. Basically, we have a really robust understanding of what this code looks like, and we can do all sorts of things with it. So the visualizer was not easy. So the engineer who worked on it would be mad if I said it was easy, but it's a lot easier than it otherwise would be because we have so much good context coming from the language server. I think that's all I had to demo. I have a roadmap slide which I can show, but I'll stop one more time and answer any questions that there may be.
Hi, Chris from here.
Yeah.
That visualizer, will it have some something to do with visual so that we could download some icons for some resources in the future?
Yeah, I think we'll eventually add the icons. So there's an ARM template visualizer that's really good that has all the different resource icons, which is nice. It'd be great if we could add those here. And then it would be also great if we could add like an export capability to say like export as PDF or even like a Visio or something like that could be pretty cool. But this is like the first bare bones iteration. And even as you have like errors in the stuff here, so if I was just to put a name here, it would know that things got screwed up and there's an error in the file and it tells you where it is. So it's really reactive to what you're doing in the code. Any other questions?
Yeah, Alex, a question on the decompiling and some of the parameter stuff you've been doing in the file. Do you think there'll be a time where you'll add decompiling to decompiling for, say, parameters to get them out into like a parameters JSON file?
Yeah, so we
I know you can use those today.
We don't have a way of generating the parameters file today, which is definitely a gap we'd like to fill, so that you can say, okay, in main.bicep, if I had a required parameter here, we could read this and say, hey, there's one parameter that needs to be provided, doesn't have a default value, let's generate the parameters JSON. And the parameters JSON file works the same way that it does today. So we haven't changed how parameters work at all. And so you can do AZ deployment create, pass it a parameters file, pass it a Bicep file. What the community has done, and truly thank God for the community because they've done some really awesome things. There is a Bicep PowerShell module out there, and they have a I think it's new Bicep parameters. I don't know the name of the command offhand, but they have a way from PowerShell reading a Bicep file, generating the parameters. And so you can go grab that. I'll try to find a link for it and share.
I actually have it. I didn't even know that that was one of the commands in there. I will go.
You know, Stefan's awesome, and
yeah,
someone had
I saw
asked.
it in the release.
Yeah, someone had asked for it, and I thought he added it, and I was like, oh, it'd be really cool if you could do this without compiling the Bicep into JSON, and he turned it around in like 12 hours, so that was pretty cool.
That's pretty awesome.
Yeah.
Just a second question on that validation page. Will it support at some point maybe like the for loops for like when you're deploying to websites here, being able to see that it's deploying, app or website 1, website 2 as part of that visualization?
Oh, yeah. I didn't even stop to think if it was doing that. Yeah, it should do that. It should say that, especially because we know the actual values because it's a variable. We should know all of that. So there's a feature, it's in our backlog. It's called constant folding. And all constant folding is like, it will resolve as much as possible as long as it knows enough information. So it should be able to basically unroll this loop because I told it exactly what was going to be provided with the variable, which is usually not the case. Usually it's a parameter and you don't know how many there's going to be. But for cases like this, it should be able to show all of that. So once we implement constant folding, and this is the really cool part, and this is, when I get excited about how like good the foundation of Bicep is constant folding is going to benefit the tooling and the validation of the code you're writing. And something like the visualization should just kind of fall out because there's just more information and more context that the visualizer can read from. So it should happen.
Well, along that line, so you're talking about like a parameters file or not being able to use that folding with a parameters file. Maybe there's a way to be able to reference a parameter file just for doing that folding or for creating a visualization to saying, here's a parameter file I'm working with and create my visualization, because like you said, a lot of those variables don't exist. They're parameters coming in.
Yeah, exactly. That we will definitely get to. So we will, there's kind of like, we want to be able to reference an existing parameters and do constant folding and more validation. We want to eventually be able to generate the file. And then we're going to kind of stop and evaluate things because we get the ask of like, what can we like bicepify the parameters file? And we've kind of pushed that down the road because we're not sure that we really need it. But if we get to that point and people are still asking for it, then we might make the parameters file a little cleaner as well.
Awesome. Fantastic. Thanks.
Yeah. Any other questions? Okay, let me pull this back up here. Okay. So you can definitely try and you can definitely contribute today. This slide is pretty old. It's an old release of Bicep. But yeah, you can just use Bicep with the CLI today. I didn't talk about installing, but if you use Bicep with the CLI in particular, Azure CLI, you don't even have to think about installing the CLI. We'll do it for you in the background and things will just kind of work without you realizing it. If you use PowerShell, Bicep needs to be installed and on your path. So Bicep is available in Chocolatey and Winget, so it's pretty easy to install and put it on your path because the PowerShell will actually use that version of Bicep, whereas the CLI will actually use its own kind of self-contained version. So it's just one little thing to be aware of there. Getting the VS Code extension is obviously pretty easy. And then, please participate in the community. So whether you want to open an issue or you can start a discussion, we have a discussions tab. If you're not sure if it like warrants an issue, you can open a discussion. That works as well. We're pretty good about publishing updates there and kind of updating our milestones. You can also follow the Twitter account where we're pretty good about publishing updates. And we're trying to get better and better at just making sure that all updates go out to all channels. We're a little bit ad hoc right now. But definitely GitHub and Twitter are the two best ways to stay in touch. And then roadmap, I guess I'm animating this, I didn't realize. So we have 0.4 coming up next week. For us, it was mostly about just improving quality. So we've just fixed a lot of bugs that we couldn't focus on before 0.3 or till 0.3. So we fixed a lot of bugs. We have a linter coming out, which is pretty cool. It borrows from kind of how C# designed their linting so that it's easily extensible and people can add their own rules. So that'll check things for like unused parameters and unused variables, and we'll continue to expand what the linter checks for. If you've used the ARM TTK, the testing toolkit, this is the spiritual successor to the TTK. You saw the resource scaffolding, and then the snippets are present as well. So that's when you saw required properties. And then this isn't on here, but there's the ARM template quick starts repo, where we have a lot of ARM template examples. We're going to move all of our Bicep samples into the quick start repo, where they do a lot more validation to make sure that those templates actually deploy and deploy to the different types of clouds that are available. So we're looking forward to being integrated with the ARM template quick start. And then 0.5 is going to be towards the end of July. And the big thing that I mentioned earlier is going to be the module registry, both public and private. We're going to try to squeeze this notion of resource type aliases. So instead of having to worry about Microsoft.compute/virtual machines and then get the API version right, we're going to try to have like the type be just virtual machines or compute/virtual machines, so that you can kind of simplify your understanding of it. And that'll light up a few other interesting capabilities there. Include file. So this is going to be an external contribution. We have a great external contributor that has been helping us out. The scenario here is if you have some content like a script that you want to use with like the deployment scripts resource or custom script extension, instead of talking to an external remote file that's on a storage account somewhere, you want to reference a local file, and then we can inject the script content into the built template and escape all of the quotes correctly and all that sort of stuff. All it means is you say include file, my script, and then we just get everything right from there, and then you can keep your code separate. That'll be a nice quality of life improvement. And then better Bicep and template specs integration. So there was a question earlier about going from that journey of Bicep through template specs and stacks. Today, you have to take your Bicep code, generate the JSON, and then create the template spec. We want it such that you can just create the template spec out of Bicep code, just like you can with a deployment. And then in the other direction, if you want to consume a template spec in your Bicep code, because someone has published a template spec and you want to use it, we'll have like IntelliSense and validation of your template specs, and it can be a source for your module. So instead of pointing to a local file or something in a registry, you can also point to a template spec that's in Azure. So we're excited about that one as well. And then we do have an internal Yammer group that you can join. This requires we need to like get you approved and get in the internal discussion, but we have a growing community there as well. Just in addition to GitHub, if you want to ask questions there, there's a bunch of people there that can help answer any questions that you have. And I think that's it. So that was a really productive hour and a half. Thank you for letting me talk to you guys for a while, and thank you for asking lots of questions that really made the experience really good for me, selfishly.
Thanks, yeah, Alex. So this is the last chance that you can ask the questions to Alex. Double checking if we have something on YouTube. No, there is no question there.
I hope that will be not a last question. Maybe in future something.
Right, you're totally right, Conrad. Actually, please don't hesitate to reach out. I hope this is not the last time we all talk, whether it's in another meetup or you just ping me on email or Twitter or what have you. I hope we continue the conversation.
Conrad, and this is the something that we mentioned with Piotr at the beginning. If everybody of you that today was listening to us and watching the Alex, the Bicep, have any request or any idea or any dream to invite somebody interesting who you would like to talk with to that kind of the meetup, just let us know. Me or Piotr, you can grab us on the LinkedIn, Facebook, and other social media. You can just, it's easy to find us, or just visit azurepoland.pl, and then we try to do the similar session like today with the Alex. That was really Great. So if there's no questions right now, so thank you, Alex, for having you today and for the session, and thank you everybody for watching and taking the active part in today's presentation.
Thanks, Alex.
Thanks, everybody.
Cheerio.
Thank you.
Thanks. It was really
Yeah.
great.
Thanks.
Thanks. Bye.